Have you ever wondered why some molecules have a positive and negative side, while others don't? Well, that's the concept of polarity. Today, we're going to explore the fascinating world of molecular polarity and how it affects everything from water to the air we breathe. So, what is polarity? Polarity in a molecule happens when there is an uneven distribution of electrical charge. But why does that happen? Let us break it down. The polarity of a molecule is determined by two key factors: the polarity of the bonds and the shape of the molecule. First, let's talk about electronegativity. Electronegativity, or EN, measures how strongly an atom attracts electrons when bonded to another atom. So, how does electronegativity affect bond polarity? When two atoms bond, the difference in their electronegativities determines how electrons are shared. If the difference in electronegativity is significant, electrons are transferred or shared unequally. This unequal sharing gives rise to different types of bonds. Let's take a look at Table 1 to better understand how electronegativity difference determines bond type. Asterisk ionic bond. When the electronegativity difference is greater than or equal to 1.7, the bond is ionic, meaning electrons are transferred from one atom to another. Asterisk polar covalent bond. If the electronegativity difference falls between 0.5 and 1.6, the bond is polar covalent, meaning the electrons are shared unequally. Asterisk nonpolar covalent bond. When the electronegativity difference is less than or equal to 0.4, the bond is nonpolar covalent, with equal sharing of electrons. Now let's explore how polarity influences the behavior of molecules. Molecular polarity plays a crucial role in determining how molecules interact with each other and their surroundings. One important concept related to polarity is solubility. Polar molecules tend to dissolve in polar solvents, like water, while nonpolar molecules dissolve in nonpolar solvents, such as oil, based on the principle that like dissolves like. This is because polar molecules, with their positive and negative charges, interact well with other polar molecules, while nonpolar molecules lack these charge separations and are more compatible with other nonpolar substances. Additionally, polarity affects intermolecular forces, which are the forces that hold molecules together. Polar molecules experience stronger dipole-dipole interactions due to the attraction between their positive and negative ends, resulting in higher boiling and melting points compared to nonpolar molecules. For example, ammonia, NH3, and hydrochloric acid, HCl, are polar, while methane, CH4, and oxygen, O2, are nonpolar. To better understand the behavior of polar and nonpolar molecules, let's look at their structure. Polar molecules have areas of positive and negative charge. Water is a good example of this. Because of its structure and the way the atoms are connected, one side of the molecule, the hydrogen end, becomes slightly positive, while the other side, the oxygen end, becomes slightly negative. This happens because oxygen pulls electrons towards itself more than hydrogen does, causing the charges to be unevenly distributed. In simple terms, water is polar because its charges are not the same throughout, with opposite charges on each side. Nonpolar molecules, on the other hand, have an even charge distribution. This indicates that there is no charge separation between the molecule's various components. When atoms exchange electrons equally, nonpolar compounds typically result. For instance, in a molecule such as nitrogen or oxygen, the two atoms have the same electronegativity, which means that they pull electrons with equal force, resulting in an even distribution of charges. Now, have you ever wondered why some molecules are polar while others are not? It all comes down to symmetry. Let's break it down. Take carbon dioxide, CO2, for example. It has two polar C equals O bonds. But because the molecule is linear and symmetrical, the dipole moments cancel out. This makes CO2 a nonpolar molecule. Now, let's look at water, H2O. Water has two polar OH bonds, but its shape is bent, not linear. This asymmetry means the dipole moments do not cancel out, making water a polar molecule. Non-polar molecules are symmetric with no unshared electrons. Polar molecules are asymmetric, either containing lone pairs of electrons on a central atom or having atoms with different electronegativities bonded. By sharing electrons by two atoms may be likened to a tug-of-war between two men. The stronger man drags the other across a central line between atoms. The shared electrons pair is attracted more strongly toward the negative atom, making them unequal or asymmetrical, creating a polar bond. Non-polar molecules, however, are formed when there is equal or asymmetrical distribution of electrons. This happens when the bonding atoms have approximately equal ability to attract elect.